can talk about datums, we have to talk about the shape of the Earth. The Earth is approximately a sphere, but because it spins on its axis, it actually bulges out a little bit at the equator. So sometimes this is called a spheroid, and other times it can be approximated by something called an ellipsoid, which is an ellipse, such as the shape here, which is spun on its axis. There's another approximation of the shape of the Earth, and that's the geoid. And the geoid accounts for the gravitational pull at all locations on the surface of the Earth. In some places, the geoid might be a really good fit to a spheroid approximation of the Earth. In other places, it might be a very poor fit. But that's just going to vary as we go around the Earth. Geoids are once again based on the gravitational field, like sea level being a flat surface. And they were commonly used when we used surveying instruments like levels and things like that relied on gravity. However, now we typically find locations with GPS coordinates, which is satellite based. So a lot of our current approximations are based on a spheroid. In both cases, what we're really trying to do is get a datum. And a datum is just an approximation of the Earth shape that we're going to use for the mapping. If we were in a very particular area, like our campus, we could find a local datum, and we would want to make that shifted to be best for the particular type of mapping that we're going to do. But because we map all over the world, we want to represent some whole world or world-centered geocentric datums where everyone in the world can use and share these quite easily. In North America, we have a number of different datums. One of the most popular datums is NAD27. NAD is short for North American Datum, and 27 refers to the year 1927. This was based on a spheroid, the Clark 1866 spheroid, and it was commonly used even throughout the 1980s as a datum for mapping. But then in 1983, the North American Datum 1983 came out, or NAD83. And this has really become the most popular since then. This is based on the GRS-80 spheroid, as opposed to this Clark 1866 spheroid, so a much more recent one. And this is typically the default. If you don't know anything more about your data, of course you would want to try to find out what the datum was, but the NAD83 is sort of the default, most common datum. Some adjustments have been made to that. These HARN, which is High Accuracy Regional Network, and it's a number of fitted points that further refines this datum. So sometimes you'll see reference to a NAD83 HARN, such as here. And also there's this World Geodetic Survey 1984. This is a geocentric datum, which a lot of especially GPS units are based on, or mapping is based on, because it's using the satellites and the GPS coordinates to better define the datum or the shape of this Earth to use for mapping. Sometimes you need to assign a datum to data, and once again, the NAD83 is sort of the default. There's all these other specialty NADs. There's the HARN again, but these specialized versions are less common. In general, people do use the NAD83, although in some cases these other datums are used. And once again, you would want to either look in the metadata for the information you have, or consult someone who is involved with the collection of that data if you're not sure. So sometimes we do data transformation, such as projecting a map from one map projection to another map projection. And sometimes when we do this, we convert from one data to another datum. And when this happens, we might have to specify what datum the original data was in and what datum we would like for the projected information. And this is, once again, this is the decision you would want to base on what the metadata is telling you about the data you have, and some information about why you're projecting into the system you want to. But if you don't do this exactly, if you pick a different datum, you're not going to get, it's not going to be exact. You could have errors up to several meters. And if you keep projecting, if you take that projected data and project it again, that data is that error is just going to get larger and larger. So once again, you should be aware of what datum you're in and what datum you'd like to go in, and these might be tied into the map projections that you're using. If you're doing this sort of transformation, you might get this sort of warning here. Typically, you can ignore this sort of warning as it indicates here, but once again, the more information you can bring in here about what geographic coordinate system. Here we see it's the North American Datum 1927, and you have some choices here for what you're projecting into, and you would want to find out that information if you could. So for GPS users, when you're collecting GPS data, you can actually collect it in more than one datum at the same time. However, some of the common datums used are NAD83, NAD27, and LAN NAD83, but there's many more. The important thing is if you know what datum that you've used for recording the information in the GPS, you can always use a different datum and get it into the proper location later. So when collecting data with the GPS, it's just important to know what datum you're using in order to collect the data.